Okay, this one looks much more involved, but it's actually not because it's already written in a factored form. So let's graph f of x equals x minus 3 quantity squared times x minus 6 quantity times quantity x minus 10 to the fifth. Now, one one inclination that sometimes people have is to FOIL all this out. I wouldn't do it. First of all, it would be incorrect algebra to take the exponent and to try to distribute it. That's just made up algebra, so don't do that. But the thing is, there's no need to write x minus 3 quantity squared as x minus 3 times x minus 3 and write that out as like x squared minus 6x plus 9. And don't do that. Like the factored form is actually great to work with. In fact, in this factored format, the three major factors are x minus 3 quantity squared, and then x minus 6, and then x minus 10 quantity to the fifth. And so you can analyze. So first of all, the roots are 3 and 6 and 10. So those are the places the number line needs to be broken up at those three places, at 3, 6, and 10. So it creates four separate pieces in the number line, and these intervals are described here. Right? So negative infinity to 3, 3 to 6, 6 to 10, and 10 to infinity. Then, pick an x value, right, in each of the intervals and write down what happens with each of the factors. Don't let to the fifth power throw you, right? Because, just once you plugged in a number x, like maybe you plug in over here between 6 and 10. Maybe you pick x to be 8, okay? Then if you picked x to be 8, 8 is an x value between 6 and 10. You plug in 8 right here for x, so you have 8 minus 10 in parentheses. Now, some people are tempted to FOIL, but I wouldn't do that. Just think about how 8 minus 10, the part in parentheses, would simplify to a negative 2. And negative 2 raised to the fifth, you don't need to actually do the math of negative 2 to the fifth. Just think about how negative 2 times negative 2 times negative 2 times negative 2 times negative 2. I said negative 2 a total of 5 times. It's really a negative times a negative times a negative times a negative times a negative. And that's a negative here, right? So we don't need actual numbers inside this chart here. We just need plus or minus signs written in. And so this don't overdo it. Don't overdo the amount of. You need this chart to be accurate, but at the same time, don't overdo the amount of arithmetic. We're just trying to figure out pluses and minuses. In the end, for f of x, which is the product of this, this, and this, like a plus times a negative is a plus, and so on. So we end up with plus, plus, minus, plus. Oh, interactive question. Explain why the second row, second column entry is a minus. So why is there a minus here? Right here where my mouse cursor is. Okay. Sometimes people are looking at the 3 to 6, this x minus 6. I just would like you to really put words to why is there a minus sign. Right here. Okay, but just after the commercial break, let's come back to this. Based on the plus, plus, minus, plus, and the fact that there should be x-intercepts or roots or zeros at x equals 3, x equals 6, x equals 10. You'll see it here in the picture. There's an x-intercept, there's an x-intercept, there's an x-intercept. And you'll see the plus, plus, minus, plus behavior. Plus, so above the x-axis. Plus again between 3 and 6. For x between 3 and 6, f of x is a plus. So, or y is a plus. So y being positive is drawn up here. And then between 6 and 10, f of x is a minus, or y is a minus. So y is negative. So between 6 and 10, the graph is drawn below the x-axis. And then when x exceeds 10, like when x is 10.1, and when x is 11, and when x is 12, and so on, y is positive, right? F of x is positive. So that's this part of the graph that's drawn up here. Now, let's just take some of this work and draw this again. I'd like to draw the picture again on the next slide because I'd like to just mention something else. Just as a reminder of some things we've seen. This picture here, for this function written in its factored form, also confirms something we saw fairly recently. X equals 3 is a 0, or a root, either word you like, of multiplicity 2, because of that exponent 2. And when the multiplicity is even, we had mentioned that the graph ought to bounce at that x value. And you see that effect right here. It bounces, right? When x equals 6, you see the multiplicity is 1. There's a hidden exponent 1. And because that multiplicity is odd, the graph pierces through. So it starts from above and goes below, right? What about at the x value 10? The multiplicity is 5. 5 is an odd number. Therefore, at 10, the graph pierces through, and we see that behavior. The graph started below and then ends above. So it goes right through at x equals 10. So right at 3, it doesn't go through. It just hits the x-axis and then bounces back up. Okay, so look, the interactive question was already mentioned. But what I'd like to do on this slide is just outline. I don't want to provide all of the details because there's a lot of details, and because I think it's important for you to make this process active. So given the function f of x equals x cubed plus 16 minus 12x, I'm starting to, even in the question, outline some ideas, hint at piecing together some of the things that we've already seen in some other recent days. And it's important that you actively think about this. This math is not a spectator sport. You might want to believe it is, but it will cause issues. You should really try to own what's going on. You can either scratch your head now or, during a quiz or test or something, right? So I want you to, based on the given function, find f of negative 4. And then once you've done that, use that to completely factor f of x. That's kind of bringing back some ideas from recent. Okay, there's going to be some work involved here. And then, based on that, describe how to graph f of x. So I would encourage you to pause the video to give some of these pieces a try, and you might do some of the work in a different manner or order than I'm going to describe, and that's okay. But just, you've got lots of tools now based on recent class days, and so go through and see if this is working for you. Okay, I hope you did actually try this, that you paused and now unpaused. Also, in the work you're about to see, some of the work that you did may be totally correct and totally relevant, but maybe in a different order, or just you thought about it differently than I did. So as I start revealing some things, we're going to just provide an answer outline as well. Not every step, because there's so many different ways to take this. And so if I reveal a step and you didn't do the work in the same manner, don't say to yourself that you're wrong. No, don't do that. But instead, maybe even if you see, oh, yeah, he did work that looks a little different from mine, pause again and then see if you can anticipate what my next step is. Again, try to make this active. I know this is a bit strange, but it's helpful to try. So f of negative 4, I didn't show plugging in negative 4 for every x, but if you do and then you simplify, you ought to get the number 0. Why is getting 0 as the y value when the x value is negative 4 helpful at all? It's because the factor theorem tells us that x minus negative 4, in other words x plus 4, is a factor of x cubed plus 16 minus 12x squared. Now what do you do if you know that x plus 4 is a factor of this? It means that if you did this divided by that, right? So this divided by that should divide cleanly with no remainder. So let's do long division. Or again, this is just an outline, so we won't show all the steps for all this, but just to outline and describe what you could be doing is, let's just rearrange the terms. You'll notice that the terms are not in an appropriate order for long division. So x cubed, oh, there's no x squared term, so we'll include a plus 0x squared. Minus 12x would be next naturally, and then a plus 16. So if you do this divided by that, right, by rearranging terms, inserting the missing quadratic term as a 0x squared, when you do the long division, again, the work is skipped here, but if you do it, and you should try it on your own, you should get a remainder of 0. If you don't get a remainder of 0, it means it's kind of a red flag, right? It says you should go back and make sure to clarify what's going on with long division, but you should get a remainder of 0, and that should be expected because we were supposed to get that when you divide by x plus 4, if that's a factor, there should be no remainder, 0 remainder. Okay, and just spoiler alert, if you've done the long division, the thing at the top of the division symbol should be x squared minus 4x plus 4 at the top of the long division symbol. That means that this function here, okay, the original function x cubed plus 16 minus 12x, or in its rearranged order or whatever, can be factored, and it is the x plus 4 factor and this quotient factor, this x squared minus 4x plus 4. And actually, Though this linear, x to the first is linear, there's a quadratic here, x to the second. This quadratic part, x to the second minus 4x plus 4, factors further as x minus 2 times x minus 2 again. So copy the x plus 4, and then it's x minus 2 quantity squared. Okay, so the original function that's up here, x cubed plus 16 minus 12x, another way to write it is x plus 4 times the quantity x minus 2 squared. And this factored format is just much nicer for graphing or for the polynomial inequality type questions. So based on the factored form, we'll see that negative 4 and positive 2 are the x values that are the roots, they are the x-intercepts, they are the zeros, whichever of those terminologies you like. And those two places break up the number line. If you cut the number line, the string, in two places, it creates three pieces. So there's the negative infinity to negative 4 piece. There's the piece between the two roots, so between negative 4 and 2. And then there's the part after the bigger root, so after 2, so 2 to infinity. Look at the two principal factors. There's an x plus 4 factor. There's an x minus 2 quantity squared factor. Not a surprise that because you have blah squared all through that row, you have pluses. When you square, you're going to only get positive values, right? The x plus 4 row, we have to be a little more careful. So when you pick x to be in the first interval between negative infinity and negative 4, maybe you pick x to be negative 10, then negative 10 plus positive 4 is negative 6, and that's a negative here. When you pick x to be between negative 4 and 2, I'm going to go ahead and just pick x to be negative 2. Okay, that's between negative 4 and 2. So when x is negative 2, I get that x is negative, but that's not the point. X is negative 2. Plug in negative 2 for x. Negative 2 plus 4 is positive 2. That's a positive, and that's why there's a plus sign here. When you pick x to be bigger than 2, maybe you pick x to be 100. Then 100 plus 4 is 104, which is positive, and that's why there's a plus sign here. A negative times a positive is a negative. A positive times a positive is a positive. Positive times a positive is a positive. So then, you really ought to try. Again, this is very much in an outline form, but based on this chart here, please try graphing by hand. Based on this minus plus plus, what should the graph look like? And then I won't do it here, but you should go check. So type in y equals this original x cubed plus 16 minus 12x. Type that into Desmos. Or if you want to type it in the factored form, that's fine too. I just swapped the order around. You can type in y is equal to x minus 2 quantity squared times x plus 4 into Desmos. Both of these pictures ought to give you the same thing, and just see how accurate your picture is. Do you have the same parts of the graph? Do you have the same x-intercepts? Do you have any extra x-intercepts? Sometimes that happens. People draw in extra x-intercepts, but there should only be an x-intercept of negative 4 and an x-intercept of 2. Do you have the same parts of the graph above the x-axis? The same parts of the graph below the x-axis?